Exploratory factor analysis. Overview, factor analysis, and then we're going to take a look at the factor analysis example facial features, and then the steps and processes of how to do the EFA, and then go to the summary. Factor analysis, what is it? It helps to identify the relational structure amongst a set of variables. That is, identify the interrelationship between different variables. For example, there are several variables they can combine together to represent a factor, and they have some relationships underlying inside of this cluster. Then we want to find out the cluster or the factor which consists of several variables. The purpose is the theory development, and it also will help us to achieve the data reduction. Types is EFA and CFA. In our class, we're going to mainly focus on the EFA. Models, there are two different models: simple conceptual model and complex conceptual model. The simple conceptual model, each measurement item primarily loads onto only one factor. That, for example, the item 1 and item 2 have relationships between them, and both of them loads onto the factor 1, while, for example, the item loads onto the factor 2, item 4, and item 5 loads on to the factor 3. Complex conceptual model, each measurement item may load onto more than one factor. That is, the item 1 may load onto the factor 1 at the same time of factor 2, item 2 loads onto the factor 1 at the same time of the factor 3, and so on. Here is the EFA example essential facial features. By looking at the facial features, we want to look at what the essential facial features for expression and communication. So look at here, we may examine the forehead, the eyebrow, the eyes, the cheek, and the upper lip, or the width of the mouth, and so on, to identify the expressions of the face. The importance of 20 specific facial features in facial recognition was measured with 80 facial images based on EFA. There were 6 factors were identified, representing 76% of the total variability in facial recognition. In order of the importance, they are the upper lip, eyebrow position, nose width, eye position, eye or eyebrow length, then face width. So instead of looking at 20 different specific facial features like what I mentioned, the forehead, the eyebrow, or the cheek, and something like that, at the end, after the EFA, we just need to calculate the 6 different factors to identify the facial expressions. So that is how we want to use the EFA, to find the relationship inside of the different small features and then combine the similar feature into a factor. Then we can achieve the data reduction as well as the theory explanation. Exploratory factor analysis. The key questions are: question 1, how many factors and what construct does each factor represent? Question 2, to which factor does each item belong? Then there are 2 main approaches to EFA. Firstly is the principal axis factoring, PAF, or principal components analysis, PCA. The PCA is more commonly used and more practiced. It reduces many variables down to a smaller number of factors, and it analyzes our variance in each variable. The model definition and assumption. We assume we have a random sample y1, y2, and until yn. Each y is the vector. The factor analysis model expresses each variable as a linear combination of underlying common factors, f1, f2 until fm. The model is as follows, like that: y1 minus mu1 equals to lambda 1 times f1 plus lambda 1 2 times f2 until the m plus the epsilon, the error term. So everything's the same for the y2, y3 until the yp and yn. Cumulativity. This is the proportion of each variable's variance that can be explained by the factors. This is how we want to calculate it. So look back at here. For the y1, we use the lambda 1, 1. Take a square root, square plus the lambda 1, 2, take a square, and plus until the lambda 1m square. So that is how we want to calculate the community for the first variable. And the results, it means the proportion of these first variables variation can be expressed by the factors. Then how many factors explain the variance? A good factor solution is one that explains the most overall variance with the fewest factor that is similar as PCA. Realistically, researchers are happy with 50 to 75 of the variance explained. Then we can still use the square plot to find the elbow. So look at the elbow, it indicates 2 or 3 factors. And then how many items per factor? The bare mean is 2 and the recommended is 3. The max is unlimited and more items means more reliables. Typically, it contains 4 to 10 different items for each factor. That is, the factor 1 may contain the previous variable from 1 to variable 5. And then the f2, the factor 2, it contains, let's see, the variable from 6 to variable 8. And make sure that each factor at least has 2 items. Otherwise, if you have just the one factor, it couldn't help us to achieve the data reduction or dimension reductions. Okay, and the factor loading can be classified based on their magnitude. We're gonna look at it in the detail in the upcoming video. That is 0.3 means minimum considerable level and 0.6 means more important than 0.5. That is the practically significant.